Alright, so you know we're looking at permutations and combinations. So I've got some formulas for both of those and some notes to make on both of them. If we're talking about permutations, what we know on permutations, it's an arrangement of objects in which order is important. Order is important. Okay, an arrangement of objects where order is important. Alright, formula for figuring this that we're going to use some today says NPR is equal to N with an exclamation point over N minus R with an exclamation point. That's the formula you need to write down. I'm going to explain all that to you here. The N and the R, okay, the number of permutations you're taking, that's your N objects, and then R at a time. So like if you got 6 objects and you're choosing 3 of them, it would be 6P3. That's how that would work. So the number that you have to choose from and how many you're choosing, that's your N and your R. Now that exclamation point, anybody know what the exclamation point means?
Yeah, it's like you're multiplying like first place.
Very good. If I gave you, this is just a side note over here, if I gave you a problem that said 4 with an exclamation point, this is one of my favorite lessons to teach because of what I'm fixing to do. This does not mean 4! Okay? Exclamation point in grammar might mean a lot of emphasis and extra loud, but it doesn't mean that in math. That's called factorial. And what Kylie was describing is correct. That means you take your biggest number, the number they give you, and you multiply every number underneath it to 1. So 4 factorial is 4 times 3 times 2 times 1. 17 factorial will be 17 times 16 times 15 times 14 times 13 all the way down to 1. Okay, so that's what these numbers here mean are the factorial. And when we looked, if you hit math on your calculator and move it back over to probability again, you have the factorial button in there. So there's lots of stuff that's useful there in the probability menu on that. I'll remember the correct term. It's objects taken R at a time.
Right.
Yep. Alright, so we're going to give us a problem here, and we'll use the formula and do it in our calculator both ways to double check it. Okay, everybody got what you need on that? Alright, this one says 10 horses are running in a race. 10 horses are running in a race. See what I did there? 10 horses are running in a race. How many different ways can the horses finish first, second, and third? First, second, third, that's 3. Okay, now this is a case where we haven't talked about combinations yet, but this is a case where I know order is important. Anybody that has any competition in them at all knows that if you're running a race, first place is more important than third place, right? So order is important on this, so that's why it is a permutation. So we're going to be finding 10 permutations of 3. Now how that sets up in the formula, on the top, it was n factorial, so that would be 10 factorial. On the bottom, it was n minus r factorial, so that would be 10 minus 3 factorial. Now this is pretty cool, the way this is going to happen. I'm going to write this out and show you this, and yes, you can just use your calculator, but this is pretty cool in the formula. 10 factorial means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, right? That's the top. On the bottom, 10 minus 3 is 7, so 7 factorial. You think, how in the world am I ever going to know that? Because 10 times 9 times 8 all the way down to 1 is pretty big. But look what happens right here. Very good, Mason. Yep. So all I got to find is what's 10 times 9 times 8. And I do that in my head, because 9 times 8 is 72. You multiply it by 10, you just add a 0 on it. So 720. So those 10 horses, this blows my mind every time I do this lesson, to think out of those 10 horses, there's 720 different ways to get a first, second, and third place. So that's craziness to me. Makes me never want to go to Oaklawn, because how am I going to win when it's that's in my. All right, check it on your calculator the way I showed you with the bell ringer. Okay, we've already got it. Everybody, make sure you can do it either way.
Where can you buy one of these at?
Walmart, Best Buy, anywhere. Where'd you say? Yeah. Probably Office Depot. I mean, or they won't be the yellow ones.
Yeah, but I need one.
I guess they could go better, you said.
They got the newer ones that's still that same model that are rechargeable. I don't know. Does anybody in here have the rechargeable?
Yeah, mine is. They're always dogs.
Oh, well, never mind that. They might not want that.
Because I never charge it. I've charged it like twice in 3 years.
Well,
That's probably why it's
I was in the market, so that was good to know. Okay,
I got mine at Best Buy though.
let's do another one of those.
Yeah, it's like that battery.
There's some even newer than that that are skinnier than that.
Really?
Yeah.
It's in color.
Yeah, I think Chloe Mitchell had one. That's
The skinnier one.
Yeah.
Okay, we got 8 people that are serving on a committee. So I got 8 people on the committee. I know my end. How many different ways can a chairperson, count these, a chairperson, a recorder, and a treasurer, there's 3, how many different ways can a chairperson, a recorder, and a treasurer be chosen for the committee members? Alright, now this type of question, people are always going to argue whether or not the order is important on that. But think about this in your terms, okay? If we're electing student council, what is, and we got president, vice president, and secretary, this is difficult to say, but as far, is there one of those positions that's more important than the other?
Yeah, the president.
President. So order would matter. You would have your top, your middle, and your bottom, right? A lot of people will say, no, the secretary's job is just as important. Maybe so. You know, I'm not demoting that in any way, but people will always want the best one first, right? So we can agree that this is 8 permutations of 3. Okay? This one will probably take me a little bit, no it wouldn't. It wouldn't take me any longer. My top number would be 8 factorial. My bottom number, 8 minus 3 factorial, is 5. So everything from 5 down cancels out. 8 times 7 is 56, and 56 times 6 is 336. Is that what y'all got? How I got what? 8 minus 3? Okay. Everybody good on permutation?
Yeah.
Yep. Combination is just as easy. The formula is just a little bit different. Alright, combination. Start you off with the page on combinations like I did permutation. C-O-M-B-I-N-A-T. Combinations. Combinations is a selection where order is not important. And that's the major dilemma, is people getting confused on which one to order and which one not. When I started y'all off on the bell ringer, I double checked just to make sure I didn't tell you the wrong thing. So make sure you got that labeled in your notes so you can always double check on it. Order doesn't matter. Okay? Like if there's 3, if I've got 3 Sonic gift cards all for $10, 3 Sonic $10 cards, and I'm drawing names. First, second, third win the same thing. So order wouldn't matter then. I wouldn't care if I got picked first or third. I still get the $10 Sonic gift card. It's not like a gold medal as opposed to a bronze, you know. So order doesn't matter on that kind of stuff. Formula for that, number, combinations, how many, is equal to, it's still n factorial on top. Bottom starts off the same, n minus r factorial, but then we have to multiply that by r factorial again. So it adds that r factorial piece on bottom. Okay, so that's the only difference in the formula there. Alright, let's try one. We order a sandwich at a restaurant. You can choose 2 side dishes from a list of 8. Okay, so we've ordered our grilled chicken sandwich, whatever. We get 2 side dishes, and there's 8 to choose from. So that means we got 8, and we are choosing 2. 2 side dishes out of 8. How many different ways can we choose our side dishes? Okay. Does it matter if I'm choosing pinto beans and fried okra for my side dishes? Does it matter if they scoop the beans or the okra first? No. They're both getting on my plate. I can eat them in any order I want, so it doesn't matter. How am I ever even going to know which one they put on there first, right? So order does not matter on this. So I'll choose 8. I got 8 choices to choose 2. Okay, so this would set up as 8 factorial over 8 minus 2 is 6 factorial times, then I have to do r factorial again. So 2 factorials there on the end, right? Alright, so 6, 5, 4, 3, 2, 1. Because the formula said to do r factorial right there. No, r is 2. Alright, so I got 8 times 7 left on the top. I got 2 times 1 left on the bottom. So 23 options. Is that what y'all got?
28.
56 divided by 2 is 28. That's right.
I kind of like this.
Alright, now it's always confusing to me to see, well, why are there so fewer combinations if order doesn't matter? When order does matter, okay, go back to the permutations when we had big answers. When order does matter, like if I'm having pinto beans and fried okra, that's one way, but then I could flip that, fried okra and pinto beans, and count it again the backwards way. Because order matters, so you got to count it ordered front and ordered the other way. So there's more options there. When order doesn't matter, pinto beans and fried okra is the same front or backwards, so I don't count it as many times. Does that make a little bit of sense about why there's not as many combinations there? Tristan's here. All right, let's try another one of those. We're listening to music. You have time to only listen to 3 songs from a playlist of 16. So we got, 3 songs from a playlist of 16. So I got 16 altogether. I can listen to 3. How many different arrangements are there for the 3 songs? Alright, people will argue on this one. Doesn't matter what order I listen to the songs in.
No.
I'm going to say no. Somebody will say, yeah, I want to listen to my favorite one first. But you're going to listen to it anyway, so I'm going to say no, it doesn't matter. So I'm going to choose, this got 16 songs to choose from for my 3. Okay, so this would be, now a bigger number here, I'm going to have a bigger answer, so expect that. 16 factorial. Minus 3 factorial is 13. Do you have to write all this out? No. I guess I'd just like to. 4, 3, 2, 1, and then 3 factorial. Alright, so I got 13 to 1 will cancel. 13 to 1 will cancel. So now I've got 16 times 15 times 14 divided by 3 times 2 times 1. I know that one's 6. I don't know what 16 times 15 times 14 is.
I got 3,000.
3,300 and what?
60 divided by
560. So on all of them that we've done so far, I was able to do in my head. That one, not so much with the 16s. I could have written out my column multiplication like you did in the 5th grade and did 16 times 15. I could have done that, but I didn't feel like it.
I think the following students to the high school office: Elizabeth Kennedy, Kaylee Wilt, Kylie Meredith, Colton Dixon, Chase Dixon, and Chloe Mitchell. Thank you.
Okay. Everybody got that? Okay, these are some common questions there. I just chose my name to use. It says, consider the letters in the word right. In how many ways can I arrange all of the letters?
What
Okay.
order doesn't matter?
Well, how many letters do I have? Let's get an N. How many am I going to arrange? All of them. So it'll be 6 again on that. Okay, so what am I going to do here? A permutation or a combination?
Oh, but it doesn't matter because you don't have to spell a word.
Right, I'm not spelling a word, that's right. So, but let's just zone in here on the GH. Would GH and HG be a separate order? Yes.
So it doesn't matter. Order does not matter. It doesn't matter.
We talked about this just a second ago. If I can flip-flop that and count it again, then that's in the permutation category, right? So I'm going to have 6 permutations of 6.
Nobody ever made you confused on which one. It was 0. Wait. Did you get 7?
Y'all cracked me up.
6 on 6. But if you factor it all out,
I'm going to show you. You're right. I'm going to show you. Okay, I'm going to go with Mason's 720 to start with. Okay? But then I got to talk about what Kylie said because that's the reason I chose this problem. It's a different type of problem. Okay, 720 is correct. There's 720 different ways I could arrange those letters. Okay, but if I used my formula that I showed y'all a second ago, I would have 6 factorial on top. Over N minus R, 6 minus 6 factorial. What is 0 factorial? Yeah, but we don't have a 0 up here in any of this, do we? No. So there's no such thing as a 0 factorial. So when that's the case, when it's the same here, you don't have that division piece at all. You could just do it as, when it's the same, when N and P are the same, you could just do it as the factorial. If you didn't want to type out that whole NPR thing. Okay, now we still got my name there. Still going to do right, so we still got an N of 6. But this time I'm only going to use 3 of the letters. So I'm going to have 6 permutations of 3 of the letters. How many different options can I have there?
Is that just for anything?
Yeah, we're just working problems.
Is that a whole new example? Then?
Yeah, this is a new problem.
I got one.
Okay, wait, can we go back to one before, which is really number? How is it permutation?
Because I can put those letters, if I put WR and then I switched it to RW, that's a different order.
Oh yeah, I'm doing
You got it. Alright, when we chose 3, I did here 6 factorial over 3 factorial. So the 3 2 1s canceled out. 6 times 5 is 30 times 4, 120. So 120 different ways I could order 3 of them. Say that again, Willis.
What is this?
Caitlin coughed right when you talked.
I'm sorry.
What is this one?
It was permutations again. We chose 6 letters. We had 6 letters and we ordered 3 of them. Chose 3 of them. Caitlin, you have to quit coughing. Just kidding. Just kidding.
I've already had like 4 cough drops this period. They aren't working.
Okay. What do y'all think? Permutations and combinations, pretty
I
good?
like it.
Pretty easy? Y'all always like anything y'all can type in your calculators. I know that.
Batteries will level this calculator.
Run out of batteries. Alright, well we got tomorrow. I told you I would give you the day to make sure that projects are done and ready to go, so that's tomorrow. Then Thursday, where projects are due, I'm going to take them at the very beginning, but then we're doing a lesson after that about some distributions where we got to make some tables and bar graphs and line graphs and all that kind of stuff. Okay? So that's what we got coming up the rest of the week. Everybody all right? Good deal.
Okay, I have a question about my project.